Yeah, super excited about Lakehouse IQ. It's not an assistant, okay? It's not an assistant, but it can power the assistants in Databricks. It also powers troubleshooting. It also powers when you're running the jobs or the workflows, all these kind of things. It hooks in to Lakehouse IQ, which then has all the semantic information from Unity Catalog. So that's why Unity Catalog is so important. You're going to hear about Unity Catalog again and again today. OK, so we're very excited about that. That's the strategy for many years to come. And we're just taking a first step towards that, right? It's not yet in a place where just English is enough to get any insight you like. But it's one big step forward in that direction. OK, so that's about democratizing data to every employee. So anyone can ask questions from data eventually. OK, so what about the right-hand side? How do we democratize AI? How do we democratize generative AI? How do we get every organization on the planet to be able to infuse generative AI into their applications? Okay? And we really believe at Databricks firmly that you should own your own machine learning models, your own generative AI models, your own LLMs, and you should train them on your own data, and that's what's going to set you apart in your industry. Okay? We really believe in that. And you might ask, OK, but why should we do that? You know, there's already models. We can just use them. Why should you build your own model? Okay? Well, the reason is this gives you control over your intellectual property. And what do I mean by that? What I mean by that is we think that every company on the planet is going to be a data and AI company in the next 5, 10 years. So the companies that you all represent, they will leverage data and AI, and that's how they're going to beat the competition. Okay? So the future of the organization you work at depends on you all that are here, and the models that you can actually build, and the competitive advantage you build into that model. You don't want someone else to have that, right? You want to really own that IP. So that's number one. Number two, you want to really lock down your data sets. That's what's unique. So the reason you're going to succeed in your organization, and you all will be promoted, is that you're going to leverage that data that your organization has when they're working with customers, and you can actually lock those down. They can be private, they can be secure, and you can train your own models using that data. And then the final reason is that you can actually push down the cost. Okay? So you can actually do this much cheaper. We're going to be using generative AI everywhere. Okay? And it gets pretty expensive, actually, to be able to do that really efficiently on modern hardware at scale. Owning the model will actually change that price equation rather than just relying on 2, 3 big models that just a few companies have. Okay? So that's what we deeply believe in the future. And that's why we're really, really excited that we've agreed to acquire Mosaic ML. All right? Okay, why am I so excited about Mosaic ML? Because the team behind Mosaic ML is absolutely fantastic. Okay? We love the team. We had complete alignment and vision the moment we saw them. They truly have been pushing for democratization. They call it generative AI for all. And the team is amazing. And especially the founder and the CEO, Naveen. First time I talked to him, I immediately knew I want to work really closely with him. So I'm really, really excited to welcome him to stage. Naveen, take it away, man.
Thank you. Thank you, Ali. Super excited to be here, and wonderful introduction from Ali. So I'm Naveen Rao, the CEO and co-founder of Mosaic ML. We're a relatively young company, about 2.5 years old, and we started with the premise that we really want to bring all of these capabilities of generative AI, large-scale AI, to many people. And when we started contemplating joining forces with Databricks, it was really interesting that beyond our obvious hair preferences, we actually share a lot in common. We actually see the world in a very similar way, where when you democratize technologies, the world gets better. And I love the analogy of the PC. I was one of those kids in the 80s that was programming a PC. All of the people who learned how to program happened because of that revolution. And I think we're on the cusp of something as big, if not bigger. How we see the entire world of data is going to be changed with AI. And we need to make those capabilities in the hands of as many people as possible. So let me talk about those 3 points that Ali mentioned earlier. These are really front and center to what we've been building, and that's why the alignment between our companies is so tight. So control, privacy, and cost. How do we address those things? And This is something that we've actually started from the very beginning, 2.5 years ago. You're always a little bit of a crazy person at first when you do something until it becomes obvious later. And I think we focused on the right things early on. So on the control side of it, actually there's a great case study by one of our mutual customers, Replit. Replit is a shared IDE. This is a programming environment. It enables people to basically pair program anywhere in the world together. And code completion, code generation is a big deal now. If anyone's written code, they know when you type, giving suggestions is now becoming the standard paradigm. It accelerates what you do, makes you more productive. And Replit really wanted to own this sort of control, and they wanted to own the behavior of the model because they actually had a lot of insights from their customers on how they could best serve them, rather than a centralized model built by somebody else. So they took Databricks, built an ETL pipeline on it, cleaned their data, and actually had a very high quality data set. And they had another constraint, which was they wanted the latency time to be very fast. Like while you're typing, they wanted to produce code, or when you type English, it produces code right away. They didn't want to have to wait for that, like seconds, or even tens of seconds. So really making the model very small and having the adequate performance was very important to them. So they came to us and asked for help on how to do this, and they basically plugged their data in, along with some open source data, into our training platform and built a model in a few days, in about 3 days, that was state of the art. And again, it came down to the fact that they were able to leverage both Databricks capabilities and Mosaic MLs, and it kind of worked on the first try. That's quite amazing. We love this use case because we believe this is sort of the paradigm of the future. We're seeing every company that uses data warehouses and analytics tools, data filtering ETL pipelines, then plugging it into generative AI to produce a model, then serving that model back to their customers in their front-end application. It's privacy. Part of it was in this Replit example that I just mentioned, but really what we focused on from the very start was respecting data privacy. We believe that that's actually critical to scaling generative AI capabilities and democratizing them. If you don't actually have technologies that can enforce data privacy, you end up with kind of misaligned incentives in the market. And so really giving the people the ability to build solutions on their unique data, creating their own IP, is super important. And we do that through respecting data privacy. Our solution, this is a cartoon of some of our technologies. It really actually borrowed some of the ideas that Databricks had pioneered, where they can run computation on behalf of a user in a user-secure environment. Whether that be compute that's kind of supplied through us or through the user, we basically make it completely invisible for us as a company to see our customers' data, and all of the model artifacts, the weights, all of these kinds of things are written back to the user's storage. And so this is a critical thing that's, that can be enforced through technology. We literally can't see it. It's sort of a brick wall. So I think that's really important as part of our technology stack. And then cost. Actually, this is something that was a deep technology problem that we tried to innovate on before a lot of people. Really, the problem is simple. I have a FLOP, a floating point operation, which is sort of the basis of training a neural network. And how can I learn from data more quickly with one FLOP? Really, that was the question we asked. A FLOP costs money. It runs on some sort of a processor like a GPU. And there's operational dollars that go into keeping that GPU going. And so every flop matters. And we start throwing lots and lots of flops at problems, they actually get very expensive. Many people have probably heard numbers like GPT-3 costs millions, 10, 12, $15 million to train. We wanted to bring those costs down to something much more tractable for more enterprises to be able to approach it. And MPT-7B is one of our foundation models that we put into the open source. And we did this to get a number of builders and developers out there going and with a small bite. Actually, it's amazing how quickly the community has built stuff on this. We're completely blown away by what we've seen. It's the most downloaded LLM in history, which is pretty cool to see, and it's only a month and a half old. Anyway, this model is state-of-the-art for its size, a 7 billion parameter model. And it only costs $250,000 to build it. And that's from scratch. This is not starting from anything. This is starting from data. Our platform made this super simple. It was literally point it to the data, hit go. And we actually publish all of these numbers in our blog. We try to be very transparent about what we're doing and how much it costs to do it. By the way, and this is what we would give to a customer. This is a real number. It's not something that we squish all the margin out or something like that. This is a real number. And even bigger models, we just released last week the MPT-30B, a 30 billion parameter model that has more capabilities, more reasoning capabilities, can do better on certain kinds of tasks. And even that, it's on par, if not better, than the model that underlies ChatGPT. It's less than $1 million. We're talking like $700,000 or $800,000 to train this from scratch. It's not necessary for everyone to do that. Obviously, you can layer in with your own data. You can fine-tune. There's a lot of other approaches. But just goes to show that the order of training costs is it's hundreds of thousands for most models, not hundreds of millions. And I think I want to get that really clear to people because it is approachable. It is something you can do, and we have the tools to make it happen. And really, this is about building the best possible model for your application. Every application is a little bit different. They necessitate different performance, different behaviors, different latencies, different memory requirements, all these kinds of things. We see a world where there's millions of models out there, all solving all kinds of interesting problems and building new, interesting applications. And we have a number of customers that have been able to take advantage of this. It's been growing very fast. We've been very fortunate to be part of this industry at the right time. And it's been a ride the last few months. Really, it's just sort of taken off. We're happy to see all the great applications that our customers are building. And with that, I just really want to thank the Databricks team for the trust in us as a team. And we're really excited to serve our customers better. Let's get everybody to the forefront of AI. And really, that's been our goal from the start, and this just accelerates it. So we're super excited to be part of the Databricks family. Thank you all.
Awesome. Very excited about this. Looking forward to working together with Naveen, Hanlon, and Jonathan Frankel, the team that's behind this. When we evaluated Mosaic and we looked at the different alternatives that are out there, what's really remarkable isn't really MPT-7B or MPT-30B. It's actually the technology they've built that actually produced this, the factory that they created that produced these models. When we tried it, it just works. There's no issues. You just modify one YAML file, you set up the parameters, the heads, what kind of attention you want and how you want to tune it, and you press a button, and it just starts training it, and it just works. You don't have to worry about anything. No vanishing gradients, no stability issues, nothing. You just crunch ahead. Failures happening on GPUs, no problem. Just works, and you can just produce your own. And this is just the beginning. So I think in the next year or so, we're going to see that this is going to get easier and easier, cheaper. Every organization will be able to train their own LLMs. So we're very, very excited to be able to do that together in the future. OK, so that's about Mosaic. That's about building your own generative AI, building your own large language models, which is super important. But AI applications, building them end to end, requires a lot of other infrastructure as well, right? So how do you do that? How do you do all the things that are needed end to end for the applications to really make your company successful with data and AI? So with that, I want to really welcome to stage my co-founder, Patrick Wendell, who's a VP at Databricks, and he leads all of our ML business. So Patrick, welcome.
Hey everyone, it's great to be here. There's so many people here. This is really awesome. As Ali mentioned, I'm going to talk about our experience with customers going into production with language model applications and the infrastructure we're building to support those. It's been a completely crazy 12 months for us in seeing LLM and generative AI workloads on Databricks. I pulled some numbers. These are from yesterday. I pulled these. In the last 30 days, more than 1,500 customers have used a transformer model on Databricks. That's the underlying technology behind language models and generative AI. And our usage of GPUs on the platform is growing 25% month over month right now. That's by far the fastest growth rate we've ever seen for an infrastructure component on Databricks. So it's nuts. It's exciting. And we're spending time working with hundreds of these customers to build real applications beyond demos and deploy those in their businesses. This is an example of a few customers we're working with. I'll just mention a few. So Block on the top right, you may know them as Square. They're building a generative AI app for their internal customer support agents to help them more quickly resolve information, get more information that helps them satisfy their customers. JetBlue is a use case that's actually going to be discussed after me, so I'm not going to give that one away. Maybe I'll choose one more. So Vizio here at the bottom, that's a TV company. They have these voice remotes. You can talk into your voice remotes. Well, they love to turn those into personal assistants that can do a lot of different things for me on my TV. I'm already sitting there with my remote. So there's tons of excitement and tons of applications. And these conversations all start in the same place. They all start with a business coming to us and saying, I'm super excited. I'm a little nervous. There's transformational changes happening in our industry. There's a foundational change in technology. And how can we compete in this world? And even how can we win? How can we use this to get ahead in our market? And I always tell them the same thing. I say, I have really good news and bad news for you. And they're kind of the same thing. So the good news is that the modeling techniques, the ability to build these models are commoditizing very, very quickly. And I think that's net really good. When GPT 3.5 came out and we saw ChatGPT, a lot of people thought, oh man, this is like complete rocket science. No one will ever be able to replicate this. But 12 months later, in the proprietary model world, there's fierce competition. Prices have come down 10x. There's Google in the market. There's many others building actually quite good chat models. And even more impressively, the open source models have actually gotten pretty good. The research community is getting together. They're sharing the techniques. They're quickly catching up. And for many enterprise use cases, the open source models are very quickly approaching sort of acceptable quality for the foundation models, as Naveen just told you. So the bad news is that you get all this, but all your competitors get it too. So the model itself, the techniques of the modeling itself, is a necessary condition to compete, but it's not really a sufficient condition to differentiate yourself in the market. And I think I'm probably the 5th person to say this today, but I'll give you a little quiz to the audience. The main way that you can differentiate is take advantage of your... OK, I'm going to try that one more time. The main way that you can differentiate is take advantage of your data. Yes, exactly. Your data is hard to compete with. Your data is differentiated. So the game you need to play in generative AI is to really take advantage of the data that only you have to build great applications. And the good news is that generative AI, in my mind, finally allows you to unlock huge amounts of proprietary data you have sitting inside of your organization. So it will ultimately, I think, let companies really jump ahead in ways they couldn't before. But you need to think hard about how you're going to leverage your data. And as a result, the data needs to be at the center of your AI strategy. And this is actually something at Databricks we've really believed in for a long time, even in prior generations of ML technologies. And the way we've accomplished that is something we call Lakehouse AI. And what does that mean? It's a marketing term. But what it really means is that the core pieces of building LLM-based applications, or any generative AI application, is 3 things. It's like preparing your data for ML, so starting with really good data and preparing it in the right format to work with ML models. It's finding and tuning really good models. And then it's deploying and serving applications. That's kind of the development lifecycle for building real ML apps. And we believe that the best way to architect your platform is to do all 3 of those inside of your data platform. Not as a separate system, not as 3 separate systems, but do it with your data. And the reason is that the hardest part of each of these steps is the data part. It's collecting really large data sets. It's integrating data with your models. It's using data to observe the quality and monitoring your models in production. And we think you should do that in your data platform with the same access control model, the same data model, the same governance model, the same UIs, and so forth. So what we've done in the last year at Databricks is we've focused on updating all the key parts of our Lakehouse AI platform to work better with generative AI. There's a lot of similarities compared to conventional AI when it comes to building applications, but there's actually some very key differences too. So you'll hear a lot about these at the conference. I don't even have time to go in depth into all of them, but I'm going to tease and give you a little bit of a flavor of some of the new technologies we're releasing as part of the Lakehouse AI stack. So the first part is preparing your data. And we're super excited to announce 2 new technologies today that will be coming in, released in the coming months. The first is a native vector search capability for your document or unstructured data in Databricks. Thank you. And I'll explain a little bit more about what that is in a second. Then the other people can clap. The second is an online support for online feature serving inside of Databricks. Let me talk a little bit about what these exactly mean. They both involve taking data that you have and preparing it for use in online and real-time applications for language models. Vector search is a way to embed document-style data. So this is maybe internal business processes or documentation about how things are done in your company. If you want to hand that to a language model and retrieve relevant documents, the canonical way to do this today is to embed those in a vector space and then do a search in order to get them at the end. I'll show an example to make it a little bit more clear. And feature serving is actually very similar. It's about taking this, in this case, very structured data, data that you're explicitly deriving, and then making it available online for applications. So let me give you just a quick example to explain what these two things really mean. And the example I'm going to use is a customer support bot. So this is a generic company that has a support bot. And in this case, the customers come up and said, I guess they're a little grumpy, and they said, I like to return my last order. So if you just take this and you send it directly to a generic model or to OpenAI or whatever, it's not going to know how to answer that question, right? It's going to say, I don't understand. What are you talking about? So what you need to do is enrich this particular request with data that's specific to your company. So a common architecture we see is that your application will retrieve some information it thinks is relevant. In this example, it might go to your online feature store and ask about this particular customer. Hey, do you have any recent transactions or recent orders from this person? And then it might also go to your vector search engine and look for articles or internal documents about how returns are handled in your company. It'll get that data and then send it to a language model. And that language model, those models are actually powerful enough to take that data and generate a meaningful response. So in this case, it says, oh, you know what? Since your order was placed in the last 30 minutes, I can cancel it for you. Would you like me to cancel it? So the way it was able to learn all that context, it was able to learn that the order was recent, and then it was able to learn that you have a policy for recent orders, was by infusing the context you have from your business. So this is a very, very common pattern we see when developing applications. So I kind of skipped over one part. On the right side, we have this thing, large language model. Now that model is like the brain of the whole application. And you've heard a lot of discussions today about getting good models, building those models. We've also updated our stack in many ways to help you find, tune, and customize those language models, which play a really important part in the end-to-end application. So it goes without saying that there's great proprietary models out there, and their prices are going down. So at Databricks, we've partnered with many of these companies to provide built-in support. We handle credential management. We handle a bunch of other stuff for interacting with these proprietary models. And a lot of our customers start here because these are really good quality models in many cases. But surprisingly, when we see customers going into production, it's very common that part or all of their stack also involves an open source model, because the quality of open source models is getting good and because they're much more tunable and extensible. So this graph shows the percentage of customers, that same set in the last, 30 days, that are using open source versus proprietary models. And it can be more than 100 because many of them are trying both. But as you see, a lot are using open source. In fact, it's actually slightly more than are using proprietary models, but most customers are trying both. So to help with the open source models, Databricks is announcing an open source model library. We've done all the hard work of taking what we believe are the best of breed models in many different areas, things like general language models, but also embeddings or code generation. We've packaged them, made them available inside of Databricks, and we've also optimized them all the way to serving. Now, someone's really excited over there about this. Now, the real win in open source models is customizability. So in the coming quarters, we're going to be releasing many ways to take those open models and customize them to your enterprise use case. There's a bunch of ways of customizing these models. A very popular one is fine-tuning with additional data. So for instance, your support model, you may have 1,000 support interactions that you already know are good. You've had someone look through and say, yes, they answered these questions in the correct way. We're going to make it super easy for you to customize and tune that model with those interactions so that it can do an even better job. We're also going to support things like tuning performance, cost, and latency trade-offs for these models. So that's getting your models and tuning them, but evaluation is really important too. These models spit out answers, and they're very hard to evaluate compared to more simple types of machine learning, because the evaluation criteria are very nuanced. You want the answer to be correct, you want it to be helpful, you want it to not be biased. So we're releasing in MLflow. For those who don't know, MLflow is a very popular open source machine learning framework that includes quite a lot of experimentation features. And we're revamping MLflow to better support language models, starting with an evaluation framework. This lets you compare multiple models against each other and literally A/B test them and observe responses, say which ones are doing better and worse. This is very useful if you're, let's say, comparing a proprietary model to a SAS model or a tuned model to a not tuned model. And we're also releasing the MLflow AI Gateway, which is totally open source. It's available in Databricks as well. And this is letting you, in your company, instead of every single team setting up an account with OpenAI and setting up an account with Bard and fine-tuning this model and serving that model, you can have all your AI use cases go through one gateway and centrally manage things like credentials, rate limiting, caching, and then you can manage the models as an administrative team and even experiment, A/B test, and so forth across them. So you've got your data. You've got your models. Now the hard part begins, which is going all the way to production. There's kind of two hard things in production. The first is online serving. So what does serving mean? It means you have to have machines running that are hosting your application all the time. If they go down or fail, your application is halted. You need to monitor them and make sure it's working. And Databricks has actually had an ML inference offering for 2 years now. The growth has been really impressive. And we're super excited to announce today that we are adding GPU support in our inference offering. And we're also specifically tuning and optimizing the most popular LLM families out there. So you can have a private copy of these models with high reliability and high performance at serving time. So we plan to keep, as newer models come out, optimizing. We have a whole team that's doing that. And we're super excited, obviously, to partner closely with Mosaic as they're building better and better models. The last hard part is monitoring. It's similar to when you're evaluating. You know, these models are, in your application, are giving answers to people, and you hope that they're mostly right. But you need to really keep a close eye on them for any serious application. I think you heard the speaker from JP Morgan say, hey, we really need to be sure that this is safe and effective before we deploy it. And the only way to do that is to set up really, really high-quality monitoring. In our view, monitoring for ML models basically becomes a data problem. What I mean by that is, for one thing, you need to log and analyze every response that the model is giving to your customers. You need to correlate your model with end-to-end metrics that you're optimizing for. For instance, if you're doing a customer support model, what are you really trying to do? You're trying to optimize a few things. You're trying to avoid escalation to a human. You know, whenever I get super mad, I just say, please, I want to talk to a person, right? You want that to happen as little as possible in your customer support model. So that's actually a metric you can track. You also want to track things like thumbs up, thumbs down on the answers that the model is generating. Those become data problems, and they feed into a data pipeline that in Databricks can power a monitoring dashboard with a feature we call Lakehouse Monitoring. OK, so just to wrap it up, I know I said a lot. But if you take away one thing, it should be that to build real LLM applications, you need to focus on your data. You need to focus on your data for preparing data sets, for building models, and for monitoring and serving. And at Databricks, we believe the Lakehouse platform is the right way to do that. So I'm super excited to work with the next 1,000 customers on AI-driven applications. And to give a little bit of a flavor of what these applications look like, I'm going to invite my colleague, Casey Ulanuth, who's my product manager counterpart at Databricks, and she's going to actually give a demo of building apps on Lakehouse AI. So thank you very much.
We almost made it. Just let me log in real quick. All right. So for this demo, we're going to imagine we're the customer support team, and we're getting inundated with questions about all of our hot new releases on our open source projects. We're getting so many questions, we want to build our own customer support bot to answer all the most commonly asked questions. To do this, we're going to need to first check large SAS models. Large SAS models have an incredible amount of knowledge. But even our customers have run into the limitations here when it comes to data recency and the recency of those updates and the data these models have access to. If you look here, you can see that ChatGPT 3.5 doesn't give us a very helpful response to what is Spark Connect, a technology that we released a year ago. So our team's going to need to build a custom support bot. And we're going to need an AI platform to do this. Luckily, we have the Lakehouse AI platform. The Lakehouse AI platform is going to provide 3 ways for us to build a custom bot. The first is vector search, which is going to allow us to return relevant responses. The second is Lakehouse monitoring, which is going to allow us to monitor the quality of our AI application when it's in production. And then third is GPU serving for large language models, which is going to allow us to have fully customizable models with data security and at low latencies. So let's go ahead and dive in. The first thing we need to do is make sure this customer support bot can answer questions related to recent topics, like what is Spark Connect? Luckily, our team has a ton of documentation on this. We have documentation on all of these new features. And we just need to use that documentation to sort of help our bot along. This is where Databricks Vector Search comes in. Databricks Vector Search makes it super easy for you to index your domain-specific documents. Once you create this index, you can then use it to retrieve the most relevant documents for your whatever question is asked. So let's see this in action. Here I am in Databricks. I'm just going to initialize my vector search client. And then now I'm going to create my index. Creating an index is just a 1-line API call. All I have to do is give it an index name, and then 2 things. I'm going to give it my UC Delta table that contains all of my document chunks, and then I'm going to give it the endpoint to my embedding model. That's it. Now, because the Lakehouse AI platform is data-centric, we're going to do a couple things for you automatically. The first is, for this Delta table, any changes that come in, so as new documents come in and you chunk them, we're going to automatically sync that with the index for you. As well as we have a tight integration with model serving, so we're going to automatically embed your queries and chunks in real time. You don't have to worry about all of that. Vector search has you covered. So now let's go ahead, run this cell. You can now see we've created our index. And then now let's see how vector search really works. Vector search is going to allow us to do similarity search in here, where you're going to see I'm going to ask it a question and tell it the number of relevant documents I want it to return. So let's go ahead and run this. And then I just have this cell to actually display them. You can see it's returning 4 chunks. And if I come to the top chunk, you can see, hopefully it's zoomed in enough for the people in the back, you can see that the first document I returned a chunk from, is this Spark Connect overview, which seems extremely relevant when I'm asking it what is Spark Connect. And if we actually look at the data chunk itself, we can see that it's explaining how Spark Connect works. Seems like this could have some promising results, but how does vector search work in practice? I'm going to use the new MLflow evaluation API that's been extended to work with large language models to actually compare a vector index prompted OpenAI model versus just a generalized OpenAI model. So that's what you can see here is I have these 2 models. One's generalized, one is the custom model, so we pin that so it's first. That's going to be that vector prompted one that we just built that vector database, as well as the generalized OpenAI one. So we're going to click to this evaluation tab. We're now going to select our evaluation results. And when we do this, and I zoom in over here, you're now going to see that we're going to have a side-by-side comparison of our model outputs to see how they're performing. You're going to see the custom model, so the vector index prompted one is on the left. The generalized model is on the right. So you can see initially, the first question is, what is Spark? And so it answered what is Spark correctly, both of them. You can also see the tokens and the latency associated with each response. But now that I'm going to a technology that hasn't been released a while ago, so I'm going to Spark Connect, released last year, we can now see that our custom model using the vector index is responding correctly. So this is saying Spark Connect is a tool that allows remote connectivity to Spark clusters. Correct. If I go over to the generalized model, it's going to be a little hard to tell, but this is actually a hallucination. It's giving the answer to what is a connector, not what is Spark Connect. So now that the MLflow evaluation API has allowed me to compare my models against a set of questions, I now have confidence in which is the best model candidate for me to deploy. So I'm going to go ahead and deploy our new model, and I'm going to monitor it with Lakehouse monitoring. I'm going to come over to my dashboards, click into my auto-generated dashboard that Lakehouse monitoring provides for me. Lakehouse monitoring, as Patrick said, is a single solution across data and AI. So it's one way that you can monitor all your data and AI assets. Let me zoom in here for everyone. What Lakehouse monitoring is going to do, it's going to crawl over all your assets. It's going to generate a bunch of quality metrics for you. Again, because we are a data-centric platform, we're going to automatically store all of those quality metrics in Delta tables in your account for you. We're then going to auto-generate a dashboard on top for you to visualize results. And you can also use those Delta tables to generate alerts if things fall below certain quality thresholds. The metrics that we provide out of the box are similar to these, so like latency and toxicity if you're monitoring a large language model. If you give us your ground truth labels, we can do model performance metrics. And we also support custom metrics as well. We'll allow you to visualize your metrics over time. And then all of Lakehouse monitoring is built on top of something that we call an inference table. Inference tables are, again, data-centric approach to machine learning, which is saying we're going to capture all of your incoming requests, all your outgoing responses to your model, unpack them, store them in a Delta table, again, in your account, and then you can use this Delta table as your next training data set. Or you can use it to interactively query and debug a problematic response or any performance problems that you're having. The last thing you'll probably notice down here is there's this PII graph. We've extended Lakehouse monitoring to support PII detection. Now, where this comes in handy is I don't expect this customer support bot to have any sensitive data in it. But it turns out some of our customers are putting in sensitive data in their questions to our bot. And this is a problem because we have compliance standards we have to meet, and we can't actually leak any sensitive data to third parties. So we're going to need to replace the OpenAI model with a private model. Databricks curates a set of best-in-class open source models for us in the marketplace. We can then load any of those models into the Unity catalog, where you can use them across your organization. Once you have one of those models, you need to now deploy it as an API. And this is where Databricks model serving comes in. Databricks model serving is a low-latency, highly available model serving solution, and we've abstracted away all the complexities of the infrastructure from you. I've gone ahead in here, and I've already deployed MPT30B, which is the recent release model, on a Databricks model endpoint. In here, you can see it's using the new GPU model serving, so it's configured with GPUs. And then you may have noticed this purple icon. This purple icon is letting me know that this endpoint is optimized. Again, for those curated set of models in the marketplace, we have optimized our solutions, including model serving, to give you better performance. And in fact, with model serving, we've seen customers get up to an order of magnitude better performance with these optimizations. Now that I've got this model deployed, we're now going to swap our MPT model with OpenAI so we can have that data security and we have our fully customizable model. So now if I go back to my dashboard, I'm now going to have it grab all the data up through today when I deployed it. And so now when I change my time window of my monitoring solution, I can come down, and you can see on my latency graph that now we're getting much better performance that we've hosted the model ourselves. This is just an example of what you can achieve with Lakehouse AI, and these are just 3 of the features that we've provided. So again, we showed vector search so that you can get relevant responses. We showed Lakehouse monitoring so that you can monitor the quality of your AI applications. And lastly, we show that you have GPU serving optimized for large language models so that you can get amazing performance and data security. Those are just a handful of all the releases that we've made as an AI platform this week. But we just want to give you a sample of that. And we're very excited and cannot wait to see what you all build with it. With that, thank you. And I'm very excited to bring onto stage Sai from JetBlue, who's going to walk us through how his team has leveraged the Lakehouse AI platform to build large language models. Thanks.
Thank you, Casey. What a great time to be alive. At JetBlue, we take pride in bringing humanity back to air travel. Over the past 20 years, disruption has been part of our DNA, and we've expanded to over 150 destinations across 3 continents. And today, we're an integrated travel company with subsidiaries in ventures, but also in travel products. Scalable growth to carry 30 million passengers on an annual basis on 1,000 flights every single day is a core competitive advantage at JetBlue. In order to fuel this growth, JetBlue is at the forefront of innovation. Because we are concentrated in the world's busiest airspace, the New York City area, to solve for the complex nature of real-time operations and layers of access to information in such a complex environment, we do need a lakehouse as provided by the Databricks in order to fuel this growth with the kinds of complexities of data that we have available. Over the past 2 years, JetBlue has made great investments in enterprise data science and AI and ML. Databricks offers scalability, flexibility, and go-to-market efficiency for all of our complex use cases and products that we aim to ship out. Quarterly product prioritization is done at the C-suite level, and data teams are structured to accelerate use cases along the data value chain. So we take great pride in identifying use cases along the data value chain in order to accelerate it all the way to AI and ML, regardless of where the use cases are. Data refinement along the data value chain unlocks value from insights. Raw data is continuously hydrated, meshed, and refined by our data integrations and data engineering team to create reliable pipelines in the Lakehouse across various SLAs, regardless of what the use case is. The business intelligence and the data science team deploy the ML models using such pipelines in order to accelerate the go-to-market efficiency as well as the deployment of our products. The Databricks Lakehouse is an all-encompassing platform that fits like a hand in glove on our data value chain. Role-based governance using Unity Catalog is able to provide various teams with great flexibility and governance at the same time to serve the right documents and the right insights to the right folks across the organization. Our business intelligence team is focused on building real-time dashboards for KPI reporting and business decisions. Our operations data science team focuses on cost efficiency products, including the real-time digital twin that we'll be talking about. And the commercial data science team focuses on revenue growth products such as dynamic pricing, recommendation engines, and so on and so forth. The AI and ML engineering team is our pincer movement, or rather scouts in a battle, where they're constantly looking at the next use case to get 20% of the work done before handing it off to the respective data science team to take it through the whole deployment pattern and completion. They also maintain our internally developed AutoML and auto-deploy library called BlueML, which is completely built on the open source framework built by Databricks. And we also maintain MLOps capabilities within the AI and ML team. A great example of applying the data value chain to real-time digital twin simulator within JetBlue is our newest product, Blue Sky. It is a product that we built from scratch internally using hundreds of attributes about each and every flight that you would take at any given point in time. And we build a continually refreshed network in real time with an embedded LLM for user-friendly decision augmentation recommendations by our frontline staff. The real-time components are then cascaded and optimized to solve this multidimensional problem. Blue Sky is an ecosystem of AI and ML models with near real-time and real-time capabilities, including simulation capabilities before a decision is actually taken for the next 24 to 48 hours of the state of our operations. An LLM built on top of that supercharges the product go-to-market strategy because we're able to make decisions with less clicks to decision ratio. At JetBlue, we started our generative AI journey using, in general, an FAQ chatbot using technologies such as OpenAI, DALL-E 2.0, Hugging Face, LangChain, and even MPT from Mosaic. And congrats on that, by the way. DALL-E and LLM Ops through Databricks offers incredible LLM governance framework for our internal chatbot creations. A framework for easy LLM integration is built into every product, and it also is integrated into our existing communications platform like Microsoft Teams that our users are familiar with. So on the left-hand side, you'll see our Bluebot, which basically goes through a line of questioning regardless of what the user is. And on the right-hand side, you'll see the same chatbot integrated into a native Teams platform for our frontline staff. Unity Catalog provides role-based access to documents, and it's incredibly powerful to us because if a new employee is accessing the chatbot, they'll only be served some of the FAQ questions from our employee handbook. But if someone from finance is accessing the same chatbot, they'd be given access to some of the 10Ks and 10Qs, including some of the SAP data that they have access to. If an operational frontline staff is accessing the same chatbot, they can then access the real-time predictions made by a digital twin solution to simulate all of the different scenarios before we actually execute a decision. So this open source generative AI framework, embraced by Databricks and thus by us in return, brings our crew members much closer to the data and insights with little change management required. Generative AI is distributed at JetBlue across various phases and use cases, from FAQ chatbots to digital twin integration to role-based access into every product that we ship out, as well as now new revenue channels that we're exploring for open source LLMs where customers can create trips by planning better as well as book directly from the chatbots. And we are working right now on an aviation GPT fine-tuned industrial chatbot which will provide our technical operations teams with WebMD-style diagnosis capabilities for each and every aircraft. So we are incredibly proud of all of the work that we're doing, and thanks to the great partnership with Databricks for achieving what we have so far. We are hiring across the entire gamut, so come join our flight. Thank you.